NEC Section 408.16 addresses the requirements for single-pole circuit breakers, specifically those of the plug-in type used in electrical panels. This section focuses on ensuring safety and proper functionality within the electrical system. The core of NEC Section 408.16 dictates that single-pole circuit breakers, which provide overcurrent protection for a single circuit, must be clearly identified. This identification is crucial for electricians and anyone working on the electrical panel to quickly and accurately determine the breaker's function and its corresponding circuit. This clarity reduces the risk of errors during maintenance, repairs, or modifications to the electrical system. Furthermore, these single-pole circuit breakers must be equipped in a manner that ensures they can only be inserted into the intended current-limiting overcurrent protective device. This provision aims to prevent the installation of a breaker in an inappropriate location within the panel. Incorrect placement could lead to inadequate protection for the connected circuit, potentially causing overloads, short circuits, or even electrical fires. The design and construction of the breakers and the panel board itself must work together to physically prevent mismatching. The NEC also addresses the situation where plug-in type circuit breakers are used as replacements or spare units. In such cases, these breakers must be designed with a handle that can be removed without destroying the breaker itself. This requirement has a specific purpose. It allows for the safe removal of the breaker handle to prevent accidental switching or operation during maintenance or replacement procedures. The ability to remove the handle without damaging the breaker ensures that the breaker can be reused or safely discarded after removal. In simpler terms, NEC Section 408.16 lays out several crucial points regarding single-pole circuit breakers. Firstly, identification, ensuring each breaker is clearly marked for its intended circuit. Secondly, insertion, preventing breakers from being installed in the wrong slots. Thirdly, handle removal, allowing safe handle removal on replacement breakers. By adhering to these regulations, electrical systems are made safer, more reliable, and easier to maintain. These regulations are designed to minimize the risk of electrical hazards and ensure the proper functioning of overcurrent protection devices within the electrical panel. This section of the NEC aims to safeguard both individuals working on electrical systems and the properties they serve by promoting standardized and safe practices for the installation and maintenance of single-pole circuit breakers. In addition to the specific requirements outlined in NEC Section 408.16a, it's important to consider other relevant sections of the NEC that may impact the application of single-pole circuit breakers. For example, NEC Section 408.36 covers the overcurrent protection requirements for panel boards, specifying that each panel board must be protected by an overcurrent protective device with a rating not exceeding the panel board's rating. This requirement ensures that the entire panel board is adequately protected from overcurrent conditions. Another relevant section is NEC Section 312, which addresses the installation of cabinets, cutout boxes, and meter socket enclosures. This section provides guidelines for the proper installation and spacing of these enclosures to ensure safe access and adequate working space for electrical connections and maintenance. Furthermore, NEC Section 110 provides general requirements for electrical installations, including provisions for working space around electrical equipment, proper identification of conductors, and the use of approved materials and equipment. Adherence to these general requirements is essential for ensuring a safe and code-compliant electrical installation. It's also important to note that the specific requirements for single-pole circuit breakers may vary depending on the voltage and current ratings of the electrical system. For example, higher voltage systems may require the use of circuit breakers with higher interrupting ratings to safely interrupt fault currents. The NEC provides detailed tables and guidelines for selecting the appropriate overcurrent protective devices based on the specific characteristics of the electrical system. When working with single-pole circuit breakers, it's always recommended to consult the latest edition of the NEC and any applicable local codes or regulations. These codes provide the most up-to-date information on electrical safety and installation practices. Additionally, it's crucial to have a thorough understanding of electrical theory and safe work practices before attempting any electrical work. Working with electricity can be dangerous, and it's essential to take all necessary precautions to protect yourself and others from electrical hazards. Always to energize circuits before working on them, use appropriate personal protective equipment, and follow all applicable safety procedures. In addition to the NEC requirements, it's also important to consider the manufacturer's instructions for the installation and maintenance of single-pole circuit breakers. These instructions provide specific details on the proper handling, installation, and testing of the breakers. Following the manufacturer's instructions can help ensure that the breakers are installed correctly and function as intended. Regular inspection and maintenance of single-pole circuit breakers are also essential for ensuring their continued reliability and safety. Breakers should be visually inspected for any signs of damage, such as cracks, discoloration, or loose connections. The breakers should also be tested periodically to verify their proper operation. Testing can be performed using a circuit breaker tester, which applies a simulated fault current to the breaker and measures its response time. If a breaker fails to trip within the specified time, it should be replaced immediately. Proper labeling of circuit breakers is also crucial for ensuring safe and efficient operation of the electrical system. Each breaker should be clearly labeled with the circuit it serves, as well as the amperage rating of the breaker. This information helps to quickly identify the correct breaker for a particular circuit and prevents accidental overloads. Labeling should be durable and resistant to fading or damage. In addition to the physical aspects of single-pole circuit breakers, it's also important to consider the electrical characteristics of the circuits they protect. Each circuit should be properly sized and wired to handle the expected load. Overloading a circuit can cause the breaker to trip frequently, which can be a nuisance and may also indicate a more serious problem. If a circuit breaker trips frequently, it's important to investigate the cause of the tripping and take corrective action. This may involve reducing the load on the circuit, upgrading the wiring, or replacing the breaker with a higher amperage rating. However, it's important to ensure that the wiring is also capable of handling the increased amperage rating. Single-pole circuit breakers are an essential component of modern electrical systems, providing overcurrent protection for individual circuits. By understanding the NEC requirements for their installation and maintenance, as well as the electrical characteristics of the circuits they protect, you can help ensure a safe and reliable electrical system. Always consult with a qualified electrician if you have any questions or concerns about electrical work. Remember that electricity is a powerful force that can be dangerous if not handled properly. Taking the time to learn about electrical safety and following all applicable codes and regulations can help prevent accidents and injuries. The information provided in this narration is for general educational purposes only and should not be considered a substitute for professional advice. Always consult with a qualified electrician before attempting any electrical work. Furthermore, never attempt to work on live electrical circuits. Always de-energize the circuit and verify that it is de-energized before beginning any work. Use appropriate personal protective equipment, such as gloves and safety glasses, to protect yourself from electrical hazards. Be aware of your surroundings and avoid contact with any conductive materials while working on electrical circuits. If you're not comfortable working with electricity, it is best to hire a qualified electrician to perform the work for you. This helps ensure that the work is done safely and correctly, and that your electrical system is up to code. It is also important to keep your electrical system well maintained. This includes regularly inspecting your wiring, outlets, and circuit breakers for any signs of damage or wear. If you notice any problems, have them repaired by a qualified electrician as soon as possible. By taking these precautions, you can help ensure the safety and reliability of your electrical system. In addition to the safety aspects, proper selection and application of single-pole circuit breakers are also critical for optimal performance of electrical equipment. Selecting the correct amperage rating for a circuit breaker is crucial for providing adequate protection without causing nuisance tripping. The amperage rating should be based on the calculated load of the circuit, taking into account the continuous and non-continuous loads. The NEC provides guidelines for calculating these loads and selecting the appropriate circuit breaker size. Furthermore, the interrupting rating of a circuit breaker is also an important consideration. The interrupting rating is the maximum amount of fault current that the breaker can safely interrupt without being damaged. The interrupting rating should be greater than the available fault current at the point of installation. The available fault current can be calculated using engineering methods or obtained from the local utility company. Using circuit breakers with inadequate interrupting ratings can lead to catastrophic failures in the event of a fault. In addition to single-pole circuit breakers, there are also other types of circuit breakers available, such as double-pole and three-pole breakers. Double-pole breakers are used for 240-volt circuits, while three-pole breakers are used for three-phase circuits. The selection of the appropriate type of circuit breaker depends on the voltage and phase configuration of the electrical system. Ground fault circuit interrupters, or GFCIs, are also commonly used in residential and commercial electrical systems. GFCIs are designed to protect against electrical shock by detecting small imbalances in current flow. When an imbalance is detected, the GFCI quickly trips the circuit, interrupting the flow of electricity and preventing a potentially fatal shock. GFCIs are typically required in wet locations, such as bathrooms, kitchens, and outdoor areas. Arc fault circuit interrupters, or FSIs, are another type of circuit breaker that is designed to protect against electrical fires. FSIs detect arc faults, which are dangerous electrical discharges that can occur when wires are damaged or connections are loose. When an arc fault is detected, the FSI quickly trips the circuit, preventing the arc from igniting nearby materials and causing a fire. FSIs are typically required in bedrooms and other areas where people sleep. The use of single-pole circuit breakers, along with other types of circuit breakers and protective devices, is essential for ensuring the safety and reliability of modern electrical systems. By understanding the NEC requirements and following safe work practices, you can help protect yourself and others from electrical hazards.